Hello there guys, and welcome back to another epic inexorable maths video. In this video we're going to look at something called integration by parts for the first time. So integration by parts is essentially a method of integration that allows you to integrate sometimes products of functions. It won't let you integrate any product ever, but it's quite useful. It's also a little bit weird because, as you'll see in future videos, you can use it to integrate things that aren't products. It's a bit weird, it's quite strange, but I'm going to explain it and it will hopefully make a lot of sense. So I've got kind of like a prompt question. What is the integral of x multiplied by sine x? Now you might try to integrate x and integrate sine x together and then times them. You can't do that though, it won't work. So what we're going to do is I'm going to give you a formula basically, and I'm going to pull it out of thin air, and I'm going to show you exactly how to answer the question. And in the next video, I'm going to show you where it comes from. The clue is it comes from the product rule for differentiation, and you kind of undo it. But we'll do that in the next video. So I'm going to just kind of give you a formula. We're going to go through it. I'm going to explain how to use the formula, and then in the next video, I'll explain where it actually comes from. Okay guys, so this is the formula here in yellow for integration by parts. This is literally the integration by parts formula. So I'm going to show you exactly how to use it right now. I know it looks a little bit complicated, but actually it's really not that bad at all. It's really not. So the difference between this and the product rule for differentiation is that normally when you do differentiation, use the product rule, you are going to let one of your functions be u and the other one is going to be v. So if you wanted to differentiate x times sine x, you would say let u equal x and let v equal sine x. And then you would find du dx, you would find dv dx, and then you would use the product rule, so you kind of cross multiply. But integration by parts is a bit different. What it's saying is that what you need to start with, the integral that you start with, is going to be comprised of the product of one function u and the other function you're going to imagine that it's kind of already been differentiated. It's the derivative of another function v. So we're going to say that x times sine x is kind of like u times dv dx. I know it sounds a bit random. And then instead of differentiating u and v, you're going to differentiate u and integrate dv dx. And then you just plug them into this side of the formula. If that sounds a little bit complicated, don't worry, I'm going to show you exactly how to do this right now. So let's just dive straight into this. So one of your functions, you will label u. So I'm going to let u be x. That's one of my functions. Now, instead of letting v equal sine x, if I was using the product rule, I would do that. I'm going to let dv dx be the other function. So one of them you call it u, and the other one you call it dv dx, okay? You'll see why in a moment, okay? Now, you're then going to differentiate u, so du dx in this question, the derivative of x is 1, and you're going to integrate the other one. So v, not the derivative, integrate, so go from dv dx to just v. What will that be, guys? Well, that's going to be minus cos x, because cos differentiates to minus sine. So minus cos will differentiate to positive sine. Hopefully that makes sense so far. And then all we do is we just plug into the formula. So the integral of x times sine x with respect to x is just going to be, because this is the integral of x times sine x, is just going to be u times v minus the integral of v times du dx. So what is u and what is v? Well, u is x and v is minus cos x. So I'm going to multiply those together. That's the u times v thing. So minus x cos x. I've just times those together and I've put the minus on the front. And then I'm going to subtract the integral of v times du dx. v is minus cos x and du dx is the number 1. So minus cos x times 1 is still minus cos x, so that goes there. Okay. So we still have to do an integral. Whenever you do integration by parts, you still have to do an integral, but as you can see, this integral is a little bit nicer than this integral. So we've made the problem simpler. Now, before we actually do the integral, I personally get very confused when I'm trying to integrate trig functions, especially if there's a minus there, and there's another minus there, and it's just a bit of a mess. So why don't we, and you're allowed to do this, why don't we distribute the minus to the outside of the integral, because minus 1 is a constant, and instead of taking away the integral of negative cos x, I'm going to add 2 minuses make a plus. I'm going to add the integral of positive cos x. It's just an easier thing to do. It's just easier. Okay. And then we're going to do the integral. So we have minus x cos x. That's still there. We've not touched that at all. But what is the integral of cos x? Well, it's just sine x. So we're going to add sine x. And of course, guys, don't forget plus c. You still need a plus c. There we are. So this is the answer, guys. So the integral of x times sine x is minus x cos x plus sine x plus c. Feel free to differentiate that with the product rule if you want to check that it takes you back to x sine x, but it does indeed. So that's kind of how you use the formula. So again, one more time, instead of using, just like when you use the product rule for differentiation, when you use integration by parts, one of the functions, you label it u, and the other function, you label it dv dx. You don't do a u and a v. One is u, one is dv dx. Now, in the next video, I will derive this formula. It's not difficult to derive. It looks really random, but if you know the product rule, it's easy to get to. I will also explain to you, because this is something that you may or may not know, or maybe you had this question. If you didn't, then I'm going to bring this to your attention right now. Because you're doing different things to u and to dv dx, I mean, one of them's being differentiated, one of them's being integrated, then does it matter which one is u and dv dx? Because with the product rule for differentiation, it doesn't matter, because you're just doing the same thing to both, and the formula is kind of symmetrical. But with this one, it's not, because again, you're doing different things to different functions. And the answer is, yes, it does matter which one you label u and which one you label dv dx. If I had labeled these the other way around, so u was sine x and dv dx was x, then not only would I not be able to do the integral, like not make it simpler, but also I would be making it more complicated. The integral would literally become harder to do. So it's really important to get it the right way around. But in the next video, I will explain exactly how you determine that. So don't worry about that for now, but hopefully I just want to show you how to actually use the formula. All of the other stuff we're going to worry about later. Hopefully that was helpful, guys. Thank you so much for watching. I highly appreciate it, and I'll see you in the next video.